Think of this molecular dissociation as sort of a musical chairs. The music plays and all the atoms get up and move around. Music stops and they need to sit down, and some of them miss out on a chair.
I see. So what was iron, what was steel before becomes iron? Is that the implication?
Yes, some amount of the material. What's left.
I see. So this is a form of alchemy, technical alchemy, in a way.
And John has also experienced that in his samples. Stainless steel rusting. That's shown in figure 46.
Right.
And the samples below that, figure 48 and 49. The battery's getting low on this computer. So it's, you want to talk about figure 49?
Oh, my turn?
Sure.
Well, we're dealing here in metals that are high-grade stainless steel series that are slightly magnetic or non-magnetic stainless. Very tough stuff that was subjected and turned actually into rust during some of the experiments in the 1980s. So this is of great interest to the U.S. government and other scientists at that time, who would bring their own samples and then would classify that. These samples went under vigorous analysis at the Max Planck Institute in Germany, as well as the Toronto labs with Hathaway and Company in Toronto, Canada, and also U.S. Army Intelligence and Los Alamos, plus many other national laboratories. But what we're having here is an effect that's happening on a large scale, very little power. And very little power can be anywhere from 75 watts up in energy. But usually when you're viewing these samples, they'll start moving. Most of the time they'll levitate. Either water, plastic, steel, brass, aluminium. Sometimes a whole system will take off and hit the ceiling and vanish or disappear or be destroyed. But then we have translational movement where the whole containers are pulled along the floor, like they're lost weight and they start floating away. That was captured actually on a non-classified tape by McDonnell Douglas Aerospace Corporation, which I have a copy of that, luckily. But most of the time, with these kind of samples, they do lose. We found also that, let's see, sort of jumping around here. We found with these samples too that they're progressively out of sync with time. They're going ahead in time. Fast decay of the materials, fast rusting effects. It's been documented by the Max Planck Institute, Fraunhofer National Laboratories in Germany, and actually Berlin labs made those comments and wrote up reports on them.
Well, now that's very significant because one of the major comments in fact, I spoke today to a professional electrical engineer who said, well, that's not possible because it would require an enormous amount of energy. That is for a building like the World Trade Center Towers to be pooped, to use your term. And the fact that you're saying that these processes can take place with very little energy is really a very significant finding. And I wondered if you could explain why it is that these processes can take place with very little energy, because I think that's a key finding.
I think so too. It was really proven well with BCTV News Hour, Tony Parsons, and the reporter at that time was Alan Edwards when he accidentally cut the extension cord into the lab when we were doing a major test, which aired on the 6 o'clock news at that time. Now, what we're operating is keyways into perhaps a Casimir realm in the subatomic realm, where we have RF generating equipment, electrostatic generating equipment, along with weak nuclear forces, which are combining and linking up in time and space and opening up a gate, so that the Casimir energy can flow in and do whatever energy is required to cause these effects, like taking bars and twisting them into knots. It's a key, using very little energy as a key to open up sort of a gateway, where this energy can come in time and space, and do whatever's needed.
Very interesting.
Very fascinating stuff.
Yeah.
It's one of the big issues with the Star Wars program, but they could use that too, those kind of principles, and then juice up the great big particle beam weapons. And I've seen them in the sub basements in Nevada State University. These cannons, they look like cannons, and they're extremely well made. I would say they must have weighed many tons, and one of them was an ion cannon. And Dr. Rocher showed me this ion cannons. He said, "I'll show you a demonstration someday," but unfortunately that never happened. He should testify that this cannon existed. And I've seen others too.
So we're beginning to be able to prove means. We're just going to stop, take a break here just a moment. Welcome back. This is Vancouver Co-op Radio, CFRO 102.7 FM, www.coopradio.org. We're with two very distinguished guests, Dr. Judy Wood, former professor of mechanical engineering and expert on the 9/11 event, and Canadian scientist John Hutchison, discoverer of the Hutchison effect, and together new discoveries are being made.
Mm-hmm.
Of the application of science to these events that will hopefully bring to light how these events occurred. Well, let's resume our conversation then.
I don't know if it's the exact same thing as the Hutchison effect, but what I've learned from this is that here is something that does the same thing that we see.
Yes.
So we know it's possible.
Right.
It's not a total mystery, and it takes very little energy. And one thing I noticed from looking through the transcripts that were available in the New York Times of the first responders that were taken soon after 9/11, quite a few of them talked about the cold dust cloud. That big dust cloud we saw rolling down the street was cooler than ambient temperature. Another thing we'll notice is after the dust cloud passed, we didn't have any toasted bodies, no cooked bodies. Matter of fact, we haven't seen any evidence of anybody being cooked, which was quite interesting. We see these toasted-looking vehicles, but no cooked bodies, and reports of cooler than ambient temperature dust clouds. And when I first read that, I was wondering, could it be that the energy of the material was, they pulled out of the material, and that's why the temperature dropped? Because that was used from, if something is ambient temperature,